Good morning and welcome to the final day, the fifth day of the 16th Vermont Organics Recycling Summit, organized by the Composting Association of Vermont in partnership with the Vermont Agency of Natural Resources. The summit this year, as you guys know, is being held in conjunction with International Compost Awareness Week, the largest initiative, education and outreach initiative of the compost industry. And this year's theme is Recipe for Regeneration Compost. And we've been talking about all different kinds of organics management and regenerative ag and how compost fits in and supports all of that throughout the week. I'm Natasha Duarte, the director of the Composting Association of Vermont. To begin with, I'd like to thank all of our sponsors who make this, who allow us to provide this full week program available to all of you free of charge. Our sponsors this year are Community Bank, Eco Products, Vegware, Addison County Solid Waste Management District, Vermont Natural Ag Products, Agri-Lab Technologies, Compost Manufacturing Alliance, EcoPixel, Nature-Cycle, the Vermont Produce Program of the Vermont Agency of Agriculture, and Wasted, Separating Waste, Connecting Communities. Our featured sponsor today is Wasted, for this session, is Wasted, Separating Waste, Connecting Communities. And Thor, are you on the line? Or Kelsey? All right, well, something must have come up on their end, but I will just say that they are new. They are focusing on composting porta potties, which will be interesting in Vermont. And they are the newest addition to the VORS family of sponsors. So we really appreciate their support and that they've joined our community. And I know they're just getting going. If they do join, maybe we can flip back to them at the end of the session. But I just want to acknowledge them. And if you do have any questions, you can look up Wasted. They have sort of a landing page right now. But Thor's email address is right there. And I'm sure he would love to hear from any of you who might be interested. Today's program, Friday, May 6th, is we're going to be starting this morning with partnerships in composting technology, hearing about a few different things. Starting with depackagers and then moving on to on-farm anaerobic digestion and partnerships between farms and composters. And then today at 1, our last online session is compost, soil science, and hydrology activities for K through 12 schools. We've got a couple of very dynamic and fabulous educators who will be sharing their curriculum and activities and all kinds of things. So please join us for that as well. And with that, I'm going to stop presenting and stop sharing my screen and invite Corey Rossen. So Corey's going to be joining us. He's with Ecoverse, and he's the food waste recycling sales manager there. I'm very interested in this session because we're going to continue the conversation about depackaging and hopefully evolve some of the conversation that we've been having around that. So Corey, take it away. It looks like there's a black box. Oh, there we go. Perfect.
That was me. I apologize. I interrupted.
And before Corey starts, I'll just let folks know we're going to take questions throughout his session. It's going to be the first half of the session is on this topic, so about 40 minutes or so. And you can go ahead and type your question in to chat at any time. I will be your voice. You can also, under reactions, raise your hand. Then when we have a little pause or when we can, we'll go ahead and invite you to unmute and ask your question. So now, Corey, take it away.
Perfect. Thank you, everyone. I appreciate the invite and for everyone attending the event. Excellent to be a part of this. Just a quick note on myself. I am with Ecoverse Industries. We are an equipment supplier as well as manufacturer of organic recycling equipment, whether it be aggregate or food waste or C&D. We are in the industry of recycling and repurposing organics. Also, a bit about myself. Prior to Ecoverse, I was with an anaerobic digestion company for about 5 or 6 years. So I've been in the industry for some time. I'm just now taking over the food waste division here at Ecoverse. So As Natasha mentioned, please feel free to chime in at some point with questions or chat or raise your hand, and I will gladly address as best I can. So today we're going to talk about clean compost after food waste separation and depackaging. So as you know, the food waste has multiple applications, whether it be through anaerobic digestion, through composting, or through animal nutrition. Today we're going to be focusing on the compost end. I apologize here. And so in terms of depackaging, and I can speak best on our equipment, our Tiger Depack and our Dobstat BioPress. Here's some of our locations we have spread throughout the US and Canada. Ecoverse, we do cover North America. So I manage all the sites throughout. We are growing in the terms of our end of the equipment. The Tiger Depack itself has been around for about 10 or 12 years. The Dobstat BioPress about 5 or 6. So those are the ones I can most best address and answer. But you see it does generally in terms of regions, focus in different regions. Now that regulations are in place more so in California and New England area for yourself, there are more equipment needs out there, and therefore more recycling and repurposing of the organics. In short, in the quickest possible way to describe depackaging and how it works within the industry. So food waste, expired foods, grocery store waste, SSO, or manufactured brand destruction. Basically, it's simply put into equipment. Here would be a picture of our Tiger Depack. From there, the machine or the mechanical device will separate the organics from the inorganics, the packaging, the plastic, the aluminum, the steel, from the organics themselves. And that recyclable material will go one way off to be repurposed, and then the organics are separated and move on to the repurposed use. In this case, it'll be compost. So I have a quick little video here. Just kind of shows the Tiger Depack. I'll talk our way through it just to show what's going on, and just it'll give you a broad overview of depackaging and some of the uses and interactions with the Tiger Depack. So here first, this is a facility in Staten Island, New York. They have a cover over the hopper there to help any wildlife that might be in the area, to keep them out of the equipment. So you can see material comes in soup cans in Gaylords. This is grocery store food waste, frozen foods, 5-gallon tubs of ice cream and syrups straight off a truck. You have small packaging like the Halloween or fun size Skittles here. So really in terms of depackaging, you're managing most any type of organic packaging that can be repurposed and reused. Ice cream is a big market for Depack customers and facilities, as is bakery goods from grocery stores, and we'll go into that more in a minute here. So simple, put the depackaged material, the material into the equipment, whether it be from SSO grocery bags there and residential pickup, all the way to manufactured cans. So it's lacerated and opened in the hopper. And from that point, it's creating the separation, and it goes through a vertical mill, which you'll see here in a minute, where the actual separation takes place. And I'll go into this in greater detail in just a minute. So here's the mill where the actual separation takes place in the screening process. And from there, you see the packaging coming out. You'll see it's free of food waste, so that you're able to capture all the organics. So you have very little to no food remaining in organics on there. So this way you're able to capture near 100% of the organics going towards compost, renewable energy at a digester or animal feed. And then you'll see the organics themselves in just a minute. And here you see the organics coming out. It can come out as either a liquid, a solid, or a mixture of both here. So whether it be slurried or a dry powder, or the mixture of both here. So that's just a quick video. Feel free to chime in with any questions at any points. So the depackaging itself can take place in small compact areas. In the upper left there, that's a picture of a facility in Auburn, New York. That's an anaerobic digestion facility. In the middle there, that's in Vancouver, Canada. And for that, they've lowered their equipment down to be able to manage the tipping height a little bit better. And that's an animal feed facility. And on the far right there, that's small. That's about the size of a car. That's 16 feet long by 6 feet wide. So you can manage most any type of material in all different settings, whether it be in a barn, in a building, or in a warehouse. And so as today, to focus on the bin to compost actual process. So you have the waste streams come in any type of form, whether it be in a sloppy offload, such as a garbage truck with mixed SSO material. You have bin and recycling facilities where we have many of our customers have bin recycling programs in place with Costco and Walmart and facilities such as that, where they actually bring in truckloads of full bins, take it, dump the waste stream into our equipment, clean the containers, put them back on an empty truck, and send them back. So there's a constant rotation of material being sorted, separated, and then repurposed. And then down in the bottom there, bottom left, pure manufactured goods, pre-consumer, whether it be expired goods or a factory recall or something along those lines, where it comes straight off a truck. So just the different forms on the right there that material can come in, whether it be palleted goods, crated, gaylords, or just a pure mix of SSO material. SSO meaning source separated organics.
And Corey, we do have a couple questions I thought I'd just interject. One is, are there settings on the depackager to select default types of packaging, say a metal can setting or an ice cream tub setting, or some maybe not with those labels, but something like that where you can actually tune to what you're putting into it?
Sure. So some types of equipment do have different components that you have to add and change. I know, for example, the Scott's Depack, which you might be familiar with in your region, has different paddles and settings. So you might have to shut down for a couple hours out of a day to change from aluminum cans to PET plastic bottles. With ours, with the Tiger equipment, it's all the same material. So you're never changing any components, screens, paddles, or anything. So you can dump pallets of aluminum cans followed by steel, followed by mixed plastics, and not have to change any settings. The one setting that I would say is changed commonly is if you have a facility that wants a certain total solids percent of moisture content in their material, and I can best speak of a Tiger Depack. So if they're adding dry dog food into their Tiger Depack and they want it to come out as a slurry, you can add water or change the setting, as you mentioned, to have a slurried process come out, or slurried material come out. If you're good with just having that material come out as is, then there's no settings you have to change. But that would be the settings, would be more add water or turn off the water depending on the organics going in. But there is some equipment where you do have to actually change components, but not with ours.
Okay. And we have a couple questions that are starting to get at measuring contamination, or how much packaging ends up in the organics portion, but I imagine you're going to be getting into that. Do you want to take those now, or do you want to hold them until you sort of cover some of them?
Yeah, I'll hold those. There is some slides that are dedicated just to that, so I will hold off on that.
All right, and so folks, feel free to keep putting your questions in, and we are going to hold off on those, but I see them and we will be circling back to them.
Okay, so this is a facility in Kansas City, Missouri Organics Recycling, where they have a bin program set up where they take material from, I believe it's Kroger's, and do the recycling of the full truck to empty truck of bins to get back out into the market. And you're going to see a video here where they're actually taking and I'll talk, our way through the video as well, but they're taking the organics through the Depack. You'll see the packaging coming out the one side. The organics, then they have a couple ways to manage material depending on the moisture content needed in their compost rows. So you can see on in the left picture there, they have liquid storage containers. On dry, hot summer days, they pump the material into those liquid storage tanks and pump that underground into a mixing bin, and then add their green waste, which you'll see in the video. And from there, they have a direct, straight mixed material straight out to their compost rows, which you'll see. They also have the auger system you see on the right there, where if it's if it's been raining for 3 or 4 days, they don't want to add any additional moisture content than they need to the compost rows. They auger the material out, and you'll see in the video, kind of briefly passes through it. There's a pit of organic material where the organics are dumped into there, and then they take that and put the dry goods into the mixing bin in order to pre-process the compost and have it come out pre-mixed. So here, I'll just hit on the video here real quick. So there's their SSO material that was pulled out of the bins as they're putting it, and they can just put everything in the Tiger. So kind of as you asked if different components need to be changed, this is a mixture of every type of material going into the hopper there. I apologize for the not so steady hand in my film work. So the material goes in, it's being separated, and I'll cover that in just a minute. Here you can see the packaging comes out light, airy. It goes through basically a spin cycle in there, almost like a salad spinner, where it's cleaning and drying the packaging. And over on the left there, that was their SCADA system. There's the mixing bin. They run a 7-minute mix. So the material green waste being put into the mixing bin. There's the organics when they run dry organics that they scoop in. Right now, the organics are being pumped underground through that white PVC pipe on the right, being mixed for 7 minutes, and it comes out as pre-mixed compost. So then they just take that compost and drive it out to their rows, which are just beyond that, and they have pre-mixed, straight from a bin compost. So kind of a soup to nuts. One step takes them 7 minutes to process material from the bin, mixed into the compost row, pre-mixed. So, and they're able to control the moisture content through the Tiger. The easiest way to phrase why they do that is on those 104-degree days, if they turn on their call it sprinkler system or their watering system out in the yard, they do lose quite a bit to evaporation. So by being able to pre-mix it in the Tiger, they're able to control the moisture content, a direct mix, and out to the rows immediately.
Mm-hmm. And Corey, are there screens in there that are also helping with some of the separation, or how does that piece work?
Yes, there are. And you'll see that in just a minute. Yeah,
Great.
There are screens. Absolutely.
Great. Thanks.
Sure. So to touch on the contamination rates, so different products you can see in the upper right, the blue there. So SSO, different batches. So every scoop of source separated material, which is what you just saw in the video. Every bucket load or every conveyor belt full of material is going to be a little bit different. So through testing, you can see that different batches, you'll have different results in terms of contamination. So in the first batch, for example, there was 0.32% contamination in the organics. So your organics are actually 99.68% clean. Going off to the right, then you see another batch of SSO, grocery store waste. Here we added 15% of water, and to briefly explain that, the water comes in at 42 psi through a 2-inch piping system. So 15% water actually means we're opening the solenoid valve on that pipe 15%. So it's 15% of 120 gallons per minute water added to that. To the grocery store waste, so you have 0.18% contamination in the organics. So your capture rate is very, very good. You're at a near 100% capture rate of organics, and then within those organics themselves, you're at less than 0.2% of plastics and other waste type material. Canned chickpeas, frozen veggies, very, very simple, easy material to see the difference between separation and non-separation. Another consideration that goes back to the output of the organics and how you want to process your material. So wet organic extraction. So if you're creating a slurry, you're adding water, say through the processing, versus dry organics where you're not adding any water. You're just taking that material as is through the hopper, through the system, and then adding that to your end use. An easy way to describe the difference and why there's a difference in terms of contamination, and really in terms of this contamination, it's a contamination in the packaging. So your capture rate is not as good when you're doing dry, not adding water to processing. And the reason behind that, the easiest explanation is if you were to process pallets or loads of potato chips in bags, those potato chips will break up, crumble up, and cling to the bag. If that bag goes straight through the process without addition of any water, that clinging of the chip is going to come out the packaging. So you'll lose, small little flecks of potato chip. If you add even the slightest bit of water, you open that valve 1% or 2% just to brush quick water onto that packaging material, it's going to wash clean those crumbs, and you'll be able to you'll increase your capture rate, and still the material will come out, the plastic will come out clean and dry, so you're not adding any water weight to your transportation of your goods from the package side, and your organics are now you're capturing all the organics going through. So just some of the ways that different facilities process and manage material. So the operator can take a look at the packaging and say, back to your, changing components or not. So your operator can look at the packaging and say, hey, there's more potato chips coming out than we're comfortable with. We're going to turn up the water, or add, a pallet of milk in with a pallet of potato chips and have that milk act as the operating water in cleaning the bag. So you can do it that way without even having to add water. And from that, on site and in real time, they're able to change the outlook of the organics, capture rate, and the packaging cleanliness. So very versatile in terms of depackaging technology. In the upper left, just where some of the numbers come from, we send a lot of our material to Midwest laboratories. We do a lot of third-party testing. Our facilities are always and constantly doing different testings for either their own personal needs, within their business, or if there's some type of regulations that they need to meet, submit material information to, documentation to.
Great. One clarifying question, Corey.
Sure.
Those contamination rates are by percent weight rather than by volume. Is that correct?
Correct, by dry weight.
By dry weight. Okay. And then just before we move on, a couple things. Where does the water come from that you're adding?
So you can add water from, and I'll go back to this screen here. So you can add water from most any source. So here on the left, Missouri Organics, one of those containers is beer. They have a couple breweries around that have either expired beer or off-spec beer. So they bring it in a tanker truck, pump it in there, and they use that as their operational water at the facility. Mm. You have other facilities that have access to well water. You have recycled pond water. Some of the digesters have used digestate to flow back through there. And the last resource is always utility water, where they're having to pay for utility water. So you have the ability to connect that piping to any type of access of liquids you might have. Right. And then also, as I mentioned before, you can add, if you're processing and you put pallets of milk in, or Pepsi or water or anything along those lines, you can use that as your operational kind of wash as well.
Mm-hmm. So two more questions before you move from this slide. One, John just said capturing rainwater on site could also be cool, like in a cistern.
The facility in Seattle does that, yes.
Oh, great. Okay. And then on this slide, there was a question whether the contamination rate of packaged materials increases or not when it's mixed with the SSO. So here in the table, you're showing sort of different batches of SSO, but then also like canned chickpeas or frozen veggies. So do you have any sense of the contamination rates when it's all jumbled up?
Those, the SSO material would have the chickpeas, the frozen veggies, SSO is just a complete mixture of all material.
Okay, so just a point of clarification for our participants. So SSO, when we talk about it in Vermont in terms of source separated organics, we're really thinking of that as organics that have been taken out of packaging, right? It's already being separated from the packaging.
Okay.
So here you're talking about both unpackaged and packaged combined together. Is that correct?
Correct. Yeah.
Okay.
Yeah. I guess so. In my terminology of SSO, a good way to look at it is back rooms of a Costco or a bakery or a facility like that, where they might be managing, putting together a fruit tray or a veggie tray and the heads of carrots, but then they're also mixed with the bakery, where they're pulling the pre-packaged material off the retail floor, and it comes in the clamshells and the different saran wrapped or cell wrapped material. So SSO is what you see, just that slop of piled on material, not palleted, a mixture of everything.
Okay.
Food waste, packaged, and that packaging could be anything. And a lot of times that SSO is the most troublesome or contaminated, or not contaminated, but potentially harmful for equipment, any type of equipment, because a lot of times that's in garbage bags, so it's blind waste coming from residential, coming from the back of stores, restaurants, anything. So.
Okay. And one more question on this point before we let you move on. So how much more SSO contamination is removed at the back end when the compost is screened? And maybe you'll be getting to that because I know we talked about sort of going, all the way through this process. So feel free to defer that if you're going to cover it later.
Sure. Well, no. So I don't have a slide on that. Okay. So in order to answer that, so the easiest way to phrase it, so you have that the small percentage of contamination leaving the tiger going into compost or going to anaerobic digestion or such. So in the compost rows themselves, that small speck of material, a lot of that will burn out itself just through the process of composting at the temperature. So a lot of that will burn out. Some of it is actually utilized through the compost process of the, if cardboard goes through or cardboard casing and, have a small piece of cardboard actually is contamination in terms of leaving the tiger, but not contamination for a composter. So you have that. And then at the end of the composting, I don't, to be honest, I don't have figures on how much more is screened out for the fines of compost. But at that point, it's been minimized, one by the tiger down to this, small percentage, and then minimized again through the heat process of compost.
Yeah, and I could see that being true of some of those paper or fiber products. But then, in Vermont, part of just part of the context for our participants and you to think about as well is, is then what we're potentially talking about micro or nanoplastics, being in the resulting product.
Right, which is the big buzzword now, right?
It is, yeah. That's what we're talking about. But yeah, okay, so I know there's a few other questions, but I think you're going to be covering some of them. So please go ahead and I'll keep filtering through the chat.
Sure, perfect. Okay, so moving on. So I'll go through this quickly because these are just process, basically slides. So here's, a hopper. Here's the easiest example for me to say is this is our hopper. Other types of equipment have different means of their separation and removal. This is our example of it. So this is a Tiger Depack. There's a feed screw on the bottom, which works in collaboration with the vertical mill, which is a screen section. I'll show you in a minute. So if the goal of our Tiger equipment is to keep that vertical mill happy in terms of it's spinning at 1,000 RPMs. At that 1,000 RPMs, if it's working hard or it has hard sticky pizza dough material that's making the amperage peak or spike, it'll tell the feed screw to slow down, stop, or reverse. So the machine is constantly, its operational systems constantly talking within itself. So the Canvas system's correcting any issues. So the operator is not having to go in and interfere or mess with anything, whether you're switching from product to product or wet to dry or anything along those lines. The second auger you see on the right up there is as you can imagine, the material being pushed up the screen into the hole of the feed screw at the bottom. It starts piling up. So that secondary auger is there. The auxiliary auger pushes the material back to keep a constant flow of material while also lacerating and opening up the packaging material. On the bottom left, just an image of, feeding the tiger through a pallet tip. Here's the screen that you had mentioned before. So in the bottom of on the right there, you can see kind of the casing of the auger. So the material comes in at the bottom. You have those paddles there, which are larger paddles, about 3/4 inch, plus another 3/4 inch of bolted on material to hold them onto the shaft. So the paddles are there just to move the material up. So the packaging is lacerated and opened up, and the shaft is spinning at 1,000 to 1,050 RPMs, creating centrifugal force, forcing the organics out through the screen, which you had asked about. So a standard screen with a tiger is about 3/4 inch. We have a lot of facilities that have 3/4 inch on the bottom half there and 1/2 inch on the top. And it's actually a pretty smart concept in the sense that 3/4 inch on the bottom is the default size that's through the past 15 years of tiger been, through R&D, been discovered that is the most optimal size screen for throughput to get anywhere up to 40 tons an hour of material through, as well as the lowest percent of contamination rate, down to less than 0.5% of contamination in the organics. So the facilities that have the 1/2 inch on the top, by the time the material spins, gets up to the top like a salad spinner, it's just clean, dry packaging. So by shrinking the screen size down, you have less chance of potential contamination. So there is basically, so you're not changing any components, material to material, the machine does all the work, and the screening is in place at its optimal size and dimensions to manage that material for clean organics and clean packaging as well. On down to, so now the organics have separated and dropped down into the organic tank you see pictured below the tiger there. From there, depending on what system you're running in, whether you're running in dry mode or in wet mode or pump or auger mode, is how the material is discharged. Most facilities like this one here in the bottom left is in Austin, Texas. They have a dual discharge system. So they have the auger, which you can see on the left there. It's actually a 2-part auger. The auger on the right is managing their packaging material. The auger on the left is managing their organics. So if they're running dry or semi-dry material, they run it through the auger system and drop it into a truck and pull away off to the compost rows. If they're pumping material, I don't know if you can see that, but the pumping, the pipework actually runs along the wall and ceiling out to, they have 3 organic or liquid storage tanks outside of the warehouse there that they manage it that way. So it's very simple. And the operator would just press a button to have it pump material or have it auger material and not have to change any of the components. The machine itself will turn on and off the proper motors. If you're pumping, the augers are off, the pump's off, and back and forth. And there is an auger inside the organic tank there to keep the material flowing and smooth. And it flows in different directions. It flows in reverse, I guess is the best way to phrase it, to keep that material over top of the auger when you're running the auger system, and pushes it forward and keeps the material continuously flowing to the pump chamber there. So very simple. So in the end, the operator really only has 2 buttons ever to control. It's the feed screw speed, how fast they want to produce material or process material, and how much water they want to add or not add during the process. Here's just a breakdown of our system in terms of controlling. As I mentioned, very simple on the operator, all the way down to the control screen can be controlled on an iPhone, on a pad, on a pedestal system. Some have it on a pedestal near a doorway in the warehouse, all the way to the point where they also have like a mothership board in the main office where they can control it from the office, so they can centralize. Some of the digester facilities and larger facilities have that as a way to control all of their screens, and they see everything all at once. The only thing you cannot do remotely is for safety is power on and power off, because obviously you don't want somebody working on the machine and somebody in a separate building turning on the machine. And then you have all the way down to the bottom right where you have analytics. So the Tiger itself will manage. It'll let you know your throughput, your energy consumptions, your water absorption, however whatever detail of processing you're looking for, you can manage through the data analysis system. So you can look up most every type of input and output type of just so you know how much energy consumption is being used compared to how much material you're actually processing. A simple way also, all equipment have their safety standards. Here you see an alarm system in the bottom middle there. You see, it outlines the door. Hey, the door's open. You press alarm. It says, please shut the door. On the right there, a little bit more complex. That's a picture of one of the panels inside the electrical cabinet. It actually shows, it'll highlight and show you which breaker has tripped. In this case, a breaker tripped. You press show alarm. It tells you what the part number is and troubleshooting how to fix it. Basically, in this case, you just flip the switch, turn the breaker back on. And then in the bottom left there, we have facilities, anaerobic digestion facilities, that have certain desired total solids they want to maintain their organics being slurried at. So you have a liquid density meter. In this case, they have their liquid density meter tied in with the canvas system of the Tiger. So if their desired goal is 7% total solids, if it's coming out 8, 9, 10, or 4, 5, 6, it will tell the Tiger to open and close the valve on its own, so that, again, the operator is not having to interfere or interject. The machine is controlling everything from the material going in to the organics going out to the solid consistency of the materials going out. So you have complete control of the organics both in and out of depackaging equipment. Just another video here, real quick to show. So that video before was showing the wet processing of material in Missouri. This is a video here showing drier material. So this is photos of an animal feed facility, but it was my best pictures of what dry material looks like being processed. So you kind of have an idea of what cereal and say dog food look like going through, as opposed to mixed organics and such. So let's play on this real quick. So this is from an animal feed facility, and this is also this is a regional Tiger for you. This is in North Grafton, Massachusetts. So this is our first Tiger up in the region north of Staten Island, so our first New England one. We have another facility being taking on a Tiger next week in Berlin, Connecticut. So we do have some regional ones up there for you guys to see, so you can see some alternative equipment. Here you just see the feed screw on the bottom pushing it in, the auxiliary pushing it back. There's your clean, dry packaging coming out. And then being animal feed, so it's coming out as a dry powder, which is their preferred material, so they're not adding any water. So this is the separated organics, and then from here they put it in their dryer, and that is what the complete dry product looks like for animal feed. And again, this is your North Grafton, Massachusetts facility. Any questions?
Yeah, so we have, is now a good time to circle back to some of the other contaminant questions?
Sure, absolutely.
Okay, great.
You want me to go back screens or stay here?
I think you can stay there for now, and we'll see. Let's see. In terms of data on particle sizes of packaging remaining in the organics after depackaging. I know we talked about percentages, and you talked a little bit about the size of screens, but I don't know if that's an indicator also of the size of packaging that might be in the organic portion.
The size of the particles, we could run through, a different set of systems. A lot of one of the main tests that we always are asked, or not always asked, but is most preferred by a lot of the customers, is the TMECC 0306 and 0308. So with those testings, it's not giving us a breakdown of actual particle size, though we could request that. It's just a matter of where they're pulling out of each sieve in order to give us the results. But we're going for the overall amount as opposed to the sizes. But yes, with the 3/4 inch, it's really a 19 mil 3/4 inch screen. The contamination you would have would be obviously smaller than that. Anything larger than that would be screened out. But generally, when you see a piece of contamination, it is, your fingernail or smaller size.
Okay. Thank you. And
Sure.
then do you have, or does Ecoverse have links to any microplastic studies on the output that could be shared?
I don't have any studies, but those,
Mhm.
I could easily find and send on to you. But
Mhm.
no, that is such a buzzword and a sore hot topic right now. That
Mhm.
because
Yeah.
basically what happens is like anything. We have some facilities that have tested out smaller screen sizes than 3/4 inch and 1/2 inch, and as logic would say and show, and we have some facilities that have Sweetgo systems, shake screens after
Mhm.
a Tiger and after their depack equipment. And basically what happens is that when they put in the smaller and smaller and smaller screen sizes, it does better for their contamination results, but then they're losing a good amount of their packaging. So your
Of the
capture goes
packaging or of the organics, just so I'm
of the
sure.
organic. So
Okay.
basically,
Yeah.
so the easiest way to phrase it would be say a lima bean. So a lima bean, you would be able to capture as an organic through a Tiger, through a 3/4 inch screen.
Mhm.
Once you go down to a 1/2 inch screen or 1/4 inch screen, that lima bean now becomes waste. It's now
Mhm.
screened out. So, and if that's, so that kind of becomes the issue is the smaller the screen size, the slower you can process material because it's harder on the equipment, and
Mhm.
you get your feed screw is basically feeding the machine slower. But then also you have a better or lower contamination rate in your organics, which is good, and that might be your desired thing. But on the same note, you're losing a massive amount of those captured organics out the packaging because clumps of wet material will clump together and come out the packaging.
So it's
An
a
easy way to,
trade-off. Mhm.
I'm sorry, go ahead.
So I just said, so it's a trade-off, basically.
It's a trade-off. It's whatever the comfort level of the operator, whatever that facility's desire is. Yeah, it's a trade-off.
Mhm. Um, yeah, so one of the things, and I think part of why this is coming up, and Corey, you and I have talked about this, is, so when we're looking at depackaging and the capture rates or contamination rates, either in the organic portion or the packaging portion, here in Vermont and at the University of Vermont, specifically with Dr. Eric Roy's team, they've really been struggling about methodology to even come up with a percent contamination, kind of thing. And so I think that's part of what drives these questions, is us just really trying to understand when we hear, it's like 99.6%, like what is that other percent and how was that? And I know that's a lab specific question, and maybe we can, you shared the name of the lab that you guys use a fair amount, or your partners use. So just trying to understand, like, what are the methodologies actually that are being used to come up with those contamination rates, I think is a question we're struggling with and trying to
Yeah,
dig into.
it's a tiered
Mhm.
sieve system,
Okay.
so that it tiers down
Mhm.
to, and I'd have to look. I don't recall what the I think it's
Mhm.
listed on one of the as to how small they go before they stop
Mhm.
screening and
Mhm.
separate. Because yeah, once you get down to attempting to sort out microplastics, you've now eliminated almost all of your organics.
Yeah, and all the other stuff. Okay. And then we do have a question about if any portion of the system gets hot, and thinking Alex says, my mind is thinking that whatever plastic contamination there may be would not be subject to leaching environments, hot or lots of time or sunlight, if it's a lower temperature. So wondering, is there something that might be sort of liquefying or melting the plastic into the organics that are extracted? I haven't
Sure.
ever thought about that. Yeah, please.
Sure. So depending on the system and the process, or in the type of equipment, so I'll be as neutral as possible. But depending on and because that's a good question. So some depackaging equipment has material being processed longer, going over screening longer, or in a hammer mill separation system longer than other equipment. Some have quick process, some have longer process. So longer process, I could see where that might be an issue. To speak on the Tiger. So the material, if you were to throw a can into a Tiger, into the hopper, you would hear it, within seconds in the vertical mill and within a second or two out of the vertical mill. So with the Tiger itself, there's not enough time within the mechanical portion of the machine itself. It's being processed for maybe a second or two coming out, the other side.
Mhm.
Some of the other equipment, runs it over paddles longer, breaks it up longer, breaks it into smaller pieces longer, and that might be more of an issue. But in my experience with our equipment, it's in and out so quick that there's not that kind of time in place.
Sure. So we're going to take two more questions before transitioning over. The first from Tom is, what about replacement parts? How long before screens, et cetera, need to be replaced, and how long do the sensors last? What does a maintenance schedule look like?
Sure. So with the Tiger, there's only a few moving parts, in which case that means there's only a few wear parts. So in terms of addressing it, so in terms of maintenance schedule, really the maintenance schedule, a daily schedule is there's a brick of grease lines that you grease every 8 hours or every shift, and that's your daily maintenance. In terms of the wear parts, it's really those bottom 4 or 5 paddles. There's 19 total paddles. There's bottom 4 or 5 that touch the material first at the bottom of that vertical mill. Those have about a 2,000 hour shelf life or wear life on them. They're all hard oxed paddles, 3/4 inch steel. So you have 2,000 hours worth of material, and then again, it also depends on the material. We have a facility in Toledo, Ohio, that only runs steel and aluminum cans. So there, it's harder material on it than, say, that facility in Massachusetts, which is only running bread dough, cookies, crackers, and lighter, easier material. So that affects it. In terms of the screen, same thing with the screen. The screen, I think we've replaced maybe one screen in 14 years. So they're very well built and meant for exactly this purpose of running material daily. Everything is stainless steel on the machine, non-corrosive. The screens, to answer your question, we've had one screen where we've had to actually replace. It's actually being replaced right now as we speak, because they had some type of 30-pound sledgehammer tool that went through and ripped a 12-inch line in the screen. So the option, we've had many customers with rebar and sledgehammer heads and such go through. We've only had one other tear up until now, and it was just, as you saw, those screens look like call it a honeycomb, where it punctured one of the honeycombs, and we just re-welded that back together. So the screens are not really an issue in terms of shelf life. The machine that had that paddle go through has had their machine 6 years now, and that's their first big major repair. The only other thing really on there as wear parts are bearings, which are moving constantly. And then there's V-belts. There's 6 V-belts that drive that 1,000 RPM vertical mill. And with those, there's a safety shear in place so that if there's any harmful, there's a few in the canvas system, and to spare time, I won't go into it too far, but there's safeguards in place where if the machine senses that there's potential damage coming, meaning that the amps are spiking or the feed screw is having a hard time pushing material through, it will react as if that's an easy way to phrase it. If it's trying to push a 2x4 piece of rebar through that hole to get it into the vertical mill, it pushes on it 3 times. Once, amps out, it'll stop, it'll reverse itself, it'll try it again to clear the jam, try it again. On the 3rd time, it'll stop the machine and say, hey, there's something in here that could potentially cause harm. So there are safety mechanisms in place. But in terms of wear parts and maintenance schedules, it's pretty simple because it's so compact and concise. But there are only a few parts that are true wear parts. Okay, great. And in terms of Ecoverse ourselves, we even though the machine is built in Italy, we have we have 3 warehouses here. Our main headquarters in Cleveland, one in Reno, Nevada, and one in Ajax, Ontario. So we have millions of dollars in equipment and spare parts here for same day or next day delivery for any.
Nice. Right. So there's two more questions. I'm going to go to the most recent one just because it's a little bit related, and then we'll cycle back. So what is the cost of the Depack, and what is the return on investment? And it's a three-part question. And then what is the energy profile, but just in broad terms, like, is it efficient, or is it does it consume a lot of energy? What are operators looking at?
So it's all electric. It's very low energy consumption, and a lot of that has to do with its canvas system. It'll shut down and off systems if it senses. The easiest way to phrase it is if you turn and go away to lunch and the machine sits idle and it's running at its idle amps for a long period of time. It will shut itself down. It'll shut off the water system. If the vertical mill senses no material in the vertical mill, it shuts down the water, so you're saving on utility. It powers down into almost like safety mode, if you want to call it. So when we install the machine for some of the facilities that are running easy material, bread and cookies that are not working the machine hard, we have to tell the software system, hey, the material here is going to be pretty easy, so don't shut it down if it looks like it's not working hard. It's working. It's just easy material. So in terms of energy consumption, that is it's very low energy, and it self monitors itself with that exact purpose in mind. In terms of pricing, there's 3 different models. It just depends on, obviously we have a unit that's a 10 ton and up to 10 tons an hour, up to 20 tons an hour, and up to 40 ton an hour unit. The unit in Massachusetts is the 40 ton an hour. The one in Connecticut is the 20 ton an hour unit. So the pricing varies depending on the model, and then the configuration of if they're doing a wet system, a dry system, how far do we need to auger the material? Do they need conveyors? Because we build the conveyors for moving packaging material. If the machine is in one location and the container or compactor is across the building, then, so a lot of variables in pricing, which we can always, I'll gladly discuss that with whomever, but it's almost a facility by facility question.
Sure. Thank you. And we can certainly share out Corey's contact information when we post the recording, so folks can follow up directly.
Oh, and then also with I'm sorry, I was trying to make
okay.
those. And then also on the return on investment, which ties that all together. So I do have spreadsheets where you can fill out, and kind of the numbers in red are variables that you yourself, the customer, would fill in that match your facility. Your work hours, how many shifts you're running, what your utility rates are in your region for both water and electric, and all that will tie in. And, within the world of an Excel file, we'll all work with the formulas and give you those answers.
Great. And last question in like just a couple minutes, because we do need to change topics here in a minute, but and this may be more than a couple question, but give us an overview or a couple minute question, but give us an overview and we can always follow up with more information. So the question is, are there differences among depackaging technologies or depackager settings that would make it more or less likely that plastic packaging would get torn into micro or nano pieces? Or are there types of plastic packaging that are more likely to be torn into smaller pieces, like a rigid plastic versus a film plastic, maybe?
Sure. So easy, quick answer. So you guys your region is more familiar with the Scott's, the Thor depackaging. Mm-hmm. So they work off a hammer mill technology. So they're beating up the plastics and the packaging into small pieces in order to separate it and screen it later with larger size screens. So they have more, and even if you look at their stats, I'm not trying to badmouth anybody by any means, but even if you look at their statistics, they have a higher contamination rate than, say, Tiger. So they're beating up their material with a hammer mill. We're opening our material. We're just lacerating the material with the auger. The whole idea is to keep material and packaging as large, keep plastic pieces as large as possible to prevent potential contamination. So 2 different types of equipment technology manage the material differently. So when you're beating up the pieces into smaller pieces, you have more potential for contamination. When you're keeping the pieces larger, as we are, then you have less potential chance. And all those are figured into the numbers. in the contamination results. And I'm sorry, I
Yep.
slipped. What was
And
the second part of the question?
Part two was, are there different types of plastic that may be more
Oh, sure. Yeah,
problematic, like film plastic or those rigid
absolutely.
plastics? Yeah.
Absolutely. There's 100% different types of plastics. And the easiest example to say is at a bakery, at a grocery store, you have the clear, the clamshells with the clear, say a cake, the clear cake cover, and then the black tray of it.
Yep.
That clear cover is flexible and will go through depackaging and separate easily, not be a part of the contamination. That black tray will fracture and shatter. It's literally a stiffer, more rigid plastic, and that will shatter, and that has more. So you have, one cake going through. The lid is fine. The tray part, the plate itself is more potential because it's a more fragile, shatters reaction.
Sure. All right, great. Well, I know we could just keep on going, and I really appreciate just the opportunity for us to all continue learning more about this technology that is on the scene here. So good for us to really understand in more depth. So thank you so much, Corey, for sharing today.
Sure.
I'm going to invite you to stop sharing your screen while I introduce our next speaker. And I am actually going to be doing the slides for Jim, so I will start getting that up. So Jim Muir is the founder and CEO of Agricultural Digesters, and he's here today to talk about partnering compost companies with farms. So Jim, feel free to say hello and unmute yourself, and I will get the presentation up and going. And Jim, I did see you in the room. Hopefully you can hear me all right and hear us. Or Jim was in the room. Let's see, I'm not seeing him anymore. And Brent, who is on hand to be contributing to the discussion. Brent, did you get any message from Jim by chance?
No, he must have left, Natasha.
Okay.
He was there.
Yeah, I thought so.
No, I did not get a message from Jim.
Okay. Well, I have his slides and I know he's starting with a little 45-second video. So I'm going to Brent, maybe you can text him and just make sure that see if he's having
Sure.
any issues. And I'm going to just go ahead and so you can learn a little bit about Agricultural Digesters, which is Jim's business. We can start that with that and then see if he's able to join us again.
Cows provide milk, but that's not all. After just weeks in an anaerobic digester, manure becomes liquid gold. It's transformed into free bedding and produces electricity or natural gas, which now, thanks to new methane reduction policies, can be sold at record high prices. And the bedding itself can be sold even after it's used. So, what's stopping you from getting a digester? Too busy? Then let us help. Because developing a digester is a lot of work, including finding grant money. Time to turn your manure into liquid gold? Just call us today.
All right, so that was just sort of a little bit of background, and I'm sure if Jim were on, he would say more. Brent, any?
I texted Jim, but I have not received a response.
Okay. Well, so let's just, Brent, so Brent LeHoullier is the operation manager for Agri-Cycle Energy at the Heartland site in Vermont. And he and Jim have had a lot of discussions about this and was going to be already contributing to some of this discussion. And so maybe we'll just start a little bit with some discussion around that. And I think, Brent, maybe you can give a little intro.
Okay. Originally, when I met Jim, I was general manager of Grow Compost. And we were working with 2, maybe 3 different small farm digesters at the time, bringing them mostly liquid, which was beer waste, some dairy, but it was all depackaged and clean going to farm digesters. Jim and I connected shortly after I went to grow. We were always looking for digesters that were strategic to us as far as location, transportation. I'm sure everybody understands is a considerable cost, especially today. So, we're always working to try to minimize that to become more efficient. And Jim has many projects in the works spread out across the state. So it was to our advantage to work with Jim and find those locations that suited us and where we were picking up. So the idea was only helping him try to locate these in areas that we could contribute to, both from a liquids or in a solids food waste. And then that discussion kind of went on from how can we work with you as far as providing material, and then there's, oh, by the way, there's digested solids on the other end that might need a home. And at that time we were composting commercially at 2 sites, and always looking for new sources of material, along with us providing clean organics. And so the conversation continued. It's still continuing, and we have an interest in those solids. Again, what came up as far as
hey, Brent.
does this make sense? Is, hey, there you are.
Yeah, Jim was
Hey,
just.
yeah, boy, I apologize to everybody. I'm out in Arizona and our internet went down this morning.
No worries. So
Okay.
Jim, just to bring you up to speed, we showed the video about agricultural digesters, and Brent was just getting us going, explaining his conversations that he's had with you and the interest that they've had in those in the digestates. So I don't know if you want to just.
Well,
Yep. Go ahead.
Yeah, whatever you think is better from there. Why don't you direct me if Brent should speak a little more, and then I'll go through my presentation, or how would it best be done?
Brent, do you want to just finish your thought there? Yeah, go ahead.
Yeah, let me just finish. Again, how this would work is, us working with farmer with a digester who's looking to either sell or provide us with material, and then transporting that. And Jim and I have been talking, and Jim's been putting a lot of time and effort into seeing if there's funds available to help sort of minimize that transportation cost, which would help us out greatly as far as making that resource work for us. And so I think this is a good place for Jim to jump in and then start with what he's doing, and then how we can help him, along with other composters and greenhouses, sort of manage that material that's coming. All right, Jim.
Great, appreciate it. Okay, great. I'll jump into this then. I think it'll probably take maybe 10 minutes or so, the presentation, maybe 15, and then perhaps we can talk. But what I'll do then, Natasha, is I'll just quickly introduce myself, and then I'll pick up on our script after that video.
Sure.
Okay, great. Just interrupt if I'm in the wrong place. Appreciate everyone being on the phone today. My name's Jim Muir. I've been involved with anaerobic digesting for the past 8 years, both in the U.S. and some internationally. So I have a perspective on that. 2 years ago, I formed a biogas development company called Agricultural Digesters, which, as I mentioned, I think is a pretty good name and pretty easy to remember. Good on search engines also. Anyway, it's Agricultural Digesters LLC. Then I guess the video was played here. And then I would say, as Brent has already started, we would like to discuss the idea of sort of an informal partnership between Vermont's dairy farms and compost companies, nurseries, greenhouses, and this type of thing. It would involve dairy farms providing excess digested solids for sale and perhaps helping pay for the transportation costs in the future. I've asked Brent about that. He's joined. He's spoken to you a little bit. Unlike many people in the biogas business, I'm not an engineer or farmer. Instead, just a lifelong marketing guy who saw an untapped opportunity in the state of Vermont. As you may know, we have a program here called the Standard Offer for digesters, and that pays 2 or 3 times as much per kilowatt for electricity than any other state from farm digesters, if it's a mid-sized farm. What we're talking about is if we don't create more than 149 kilowatts. If more is made, then the price drops to, I believe, 14.5 cents a kilowatt. While I do approach these larger farms, a former German client of mine came up with a new type of digester a few years ago, and that targets medium-sized farms of approximately 300 to 700 cows. It's 100% above ground, and it only takes slurry waste, one size fits all rather than custom built. For all these reasons, and by switching from a construction-based situation where you're spending 3 or 4 months putting the digester together, you're talking more about 2 or 3 weeks. And all this, and also by not being custom sized and being limited to slurry waste, greatly reduces the overall project costs, so that the prices for these digesters is more than $500,000 less than a comparable size custom in-ground digester built in the past 10 years. And Natasha, are you showing some of the images of the digester being transported in pieces?
We were just on the slide, just sort of showing it on the transporter. Yeah, and then the next slide is the video.
Yeah, good.
Let me know when you're ready for the video.
Yeah, no, that's where we should be. And then after you've got up there for a few seconds, there's a 1-minute time-lapse video of this model digester actually being assembled. So those familiar with digesters realize this is a very different situation. So if you could run that video, it takes about 1 minute.
Sure. Here we go. And there's not volume on this one, so don't worry, folks, if you can't.
No. Be nice to be able to build it this fast.
Mm-hmm. All right.
Okay, we got it?
Yep.
Good, thanks. Okay. What this all amounts to is that today now on a Vermont farm of 300 or more adult cows, the return on investment from a digester is pretty good. And that's somewhat different than the other 49 states. I mean, it can be done there, but it's not as financially beneficial as in Vermont. And my company represents this system in Vermont. as a matter of fact, I've told Brent and Natasha earlier, I'm from Connecticut, but I saw the opportunity here between the cost of the digester and the price that Vermont pays to drive back and forth to Vermont from Connecticut for a couple of years before I, about a year and a half ago, got a place in Williston. And I thought people would like the fact that I was now living in Vermont, but they tell me that Williston is not really Vermont. I guess it's too many modern buildings and Walmarts and that kind of thing. But I like it, and it works great for me. Unfortunately, there are a couple of snags when I got here, and that is that often an anaerobic digester is built using funds from not only the REAP USDA program, but also the EQIP, which is offered by NRCS. That's the case in Pennsylvania and other states. However, when I got here, I was told that Vermont does not prioritize greenhouse gas reduction, or does not score higher than water quality, and especially in the Lake Champlain watershed. So that the farms I'm talking to might likely not get EQIP funds. That may be changing a little bit with the new administration in Washington, which is now pushing the use of many funds, probably including the EQIP funds for a digester. But eventually I was able to make a case to some degree anyway that digesters are going to help water quality. And to do that, we kind of came up with a watershed digester concept. And on the screen, I'm not sure you can see it shortly, there should be a flow diagram of this. And it may not be large enough to read, but certainly be glad to send you a copy if you'd like to have one. Essentially what this is doing, first the manure with phosphorus is digested, and then it is separated into liquid and solid fractions, and both contain a certain amount of phosphorus. We'll use the separated solids for bedding, but the system often makes twice as much as needed, and we're hoping to transport that portion off the farm. By the way, before I leave it, there's also another exciting new opportunity, and that's the Climate Smart Commodities Act, which did just come out, and it will hopefully, to some degree, supplement the money that the farms hope to get from the EQIP. And we're putting that together now, and should have an answer in July on that. I'm not sure where we are, but I'm hoping to come up soon to a slide of someone's hand holding holding some of the digested solids. You got that?
Okay. Yep.
Okay, good. So using these separated solids, which to me look, smell, and feel like dirt, will create an opportunity, we feel, for Vermont compost companies to create revenue using excess or used digested solids from farm digesters. And the sales should in return result in more anaerobic digesters, which capture and reduce greenhouse gases by converting them into renewable energy, heat, and as we mentioned, these digested solids. My company, Agricultural Digesters, using a planning grant from USDA called the Value Added Products Grant, or the VAPG, will meet with companies over the next few months about utilizing used or excess digested solids in compost. We would also be open to meeting with greenhouses, nurseries, about using these solids as soil amendment. Wanting to obtain a fair and consistent price for farmers and investors, Agricultural Digesters will also apply for a working grant from VAPG, Value Added Products, later in 2022 to reduce the cost of transportation, which, as you know, is, or as you've told me, is the major factor in composting profitability. In this working grant, we have the planning grant, we already received it, But in the working grant, there could be as much as $250,000 available if we're successful in getting this to somewhat offset the transportation costs. In addition, rather than just selling the excess bedding solids, we see an option to partially or fully compost the solids at the farm itself. Brent, I don't know if you mentioned it, but could you give me some of the thoughts about that, how that might work? Or have you already?
No, I have not. So, in our discussions, what are the possibilities and what are the options on farm? And, some of that discussion involved the farm itself composting on site with waste haulers like myself contributing organics to those piles, and then actually maybe lending expertise on how to build and rotate and water and so forth, and putting together the recipe and the mixture for those piles, and then in return buying that compost once it matures, and then adding it to our stock and then selling it seasonally. So those are some options that we've discussed that are other than us as a composter coming up and hauling the solids away and then composting on sites off the farm. So those are just some ideas that Jim and I have sort of tossed around. Again, if there was a digester in an area where I could pick up organics and then draw, and then offload locally, that certainly helps us in our business model of transporting waste organics. So I guess I'll return the discussion back to you, Jim.
Great. Thanks, Brent. I guess another quick question.
Jim, you there?
Yep, I can hear him.
Yes, can you hear me? Okay, good. Okay, just by the way, Natasha, I can't really follow myself. Is my voice strong enough? Am I speaking? Can it be heard?
Yes. Yeah, I think so.
Okay, great. Okay. Just a quick review of something, and that's the origin of these digestates. I know probably several of you know the anaerobic digesting process, but I'll just quickly describe it, and there's another chart here about that. Essentially, animal manure plus food waste is placed in a sealed tank without oxygen for 17 to 25 days. That depends on the type of the system, whether it's a plug flow, as DVO has built many of those in Vermont, or a complete mix, which is what this digester is. And there's no oxygen, and it's heated to 100 degrees. Bacteria forms under these conditions, and methane and carbon dioxide are released. Greenhouse gases. These released gases then power a combined heat and power generator, while any excess biogas is flared off. So that's also destroyed, which is a good thing. The electricity created is sold to the grid, or in some cases used off-grid at the farm. The heat from the generator can be used in farm site buildings or any buildings that are located at the farm site. While the digestate looks like manure, it, as I mentioned, loses most of its odor, and it's largely pathogen-free when it first comes out of the digester. It can then be separated into liquid and solid fractions with a screw press separator. These solids look, feel, and smell like soil, and they're useful material for compost. One question that might be asked is whether solid digestate from 100% or 75% manure digesters makes as good or better compost than raw manure and other materials, and what are the benefits to the compost company. The material contributes 2 of the 3 main ingredients of compost, moisture and carbon, the fiber material. When with the composter providing food, nitrogen. For more detail, I have a report titled Digestate Analysis Study, and this is from Penn State and a company I work with called Team Ag down in Lancaster, PA. Lancaster, PA, in my mind, has the most effective and largest digester cluster in the USA. So they actually have a community, a farming community built around exchanging information on their digesters. The new digesters in Vermont are all primarily manure and have some food waste, just like the Pennsylvania farms that I'm familiar with. And anyway, this report is there. It's got a breakdown of exactly what's in it. I just put a little bit from the top of the report on the slides, but I have the full report, and I think Brent has looked through this. Brent, did anything strike you when you looked at that report, or was it kind of what you expected?
No, it's it certainly was what we had expected. We have in the past used manure as part of materials for the compost. This is sort of a step down from that. It's not nearly the potency of straight manure, but it provides that fiber that we're really looking for. We typically use woody material as far in building compost. I'm hoping, and we'd like to do some trials with these solids to see if the breakdown is faster, more thorough than we're finding with wood chips. With chips, it seems like we're getting a fairly high percentage of breakdown, but not complete. And so the screening process is really important at the end to separate that. Where I'm hoping these solids sort of break down completely, look into more of a soil, so that the screening isn't so essential. But yeah, we're looking forward to at least doing some tests with this stuff and seeing over a 28-day to 60-day period what the breakdown is.
Okay. Thanks. And as I think it's already been mentioned, there's also the possibility of partially composting on the farm, and we want to look into that. And that would include concrete flooring or some way to ensure that the phosphorus was not leaking at the farm. As mentioned, it's a big thing about the possibility of getting EQIP funding in the future, that we show that we are shipping at least some phosphorus off the farm. We realize the cost of collecting and transporting solids off the farm to the compost company or customers is very important. And we feel this might be done by the compost company at a reduced price for the material, and then later at a higher price by the compost company when there's hopefully some reduction of the fuel costs through the VAPG grant. Solids could also be transported by the farmer or an independent trucker. I know some farms with digesters they themselves truck their excess bedding solids to another farm, and the other farm pays them probably somewhere in the area of $10 a yard or perhaps more. Something that isn't immediately apparent but still important, I think, is the potential marketing and public relations benefit to compost companies for utilizing Vermont digested solids, or greenhouses or nurseries. Offering compost that supports Vermont's farms in the compost company's signage or your advertising, or maybe any kind of packaging someone would do with this material, I'm quite sure would create new customer enthusiasm. Points that could be emphasized in promotion would be, first, the removal of some phosphorus, which will improve water quality in the Champlain watershed, and ECIP has already told me, and NRCS has already told me that they understand this benefit. Secondly, the digested solids are considered organic. Third, farm digesters capture and reduce the greenhouse gases that cause global warming. And then finally, and most important, purchasing this compost provides needed financial support for Vermont's family farms, especially the smaller farms that are struggling. And this is a huge part of the Vermont brand, and for tourists to be able to drive up to Vermont and drive along and see ski resorts and dairy farms. Farms have shown interest in building a digester and then selling their digested solids. I have right now about 12 or 13. 7 are in Franklin County, 3 are in Addison, 1 is in LeMoyle, 1 in Caledonia, 1 in Windsor, and 1 in Chittenden. I think that improving water quality and reducing greenhouse gases is very important to all of us. But our focus in creating this cooperation is still economic. You in the compost business need to make a profit, and everyone is familiar with the financial struggles, as I just mentioned, of Vermont's farms over the last few years. Although milk prices and milk price margins are going up somewhat now. So our job will be to show the value of our solid digestate and to make sure that the economics, including transportation, work. Again, thanks very much for your time. I'm sorry I didn't make it on the screen, but hopefully my voice is held up, and I look forward to meeting anyone in the future who'd like to discuss this.
Great. Thank you so much, Jim and Brent. Jim's contact information is still up there on the screen and will be included when we post the recording of this. So anyone who's interested in learning more, feel free to reach out directly to Jim. I'll just share that John says at EPA, we have an anaerobic digester survey for facilities to accept food waste. Vermont is smaller, but has good representation from farms, standalone digesters, and WRRFs. Great job. So there's definitely interest and some activity in our state around anaerobic digestion and as a way of dealing with both manures and food waste. We are unfortunately at the top of at the end of the session at 11:30, just a few minutes past, and we hope to see some of you back for our last virtual session at 1 p.m. Connecting School Compost to Soil Science and Hydrology for K through 12 schools. Thanks again to Corey and Jim and Brent and to all of our participants for engaging with us today, and we'll see you again at 1 o'clock. Take care.